So we had a recent homework assignment where we were working with average rate of change and the slope of a curve at a point. And I just want to run through my version of the solutions for these so that you can get an idea of what it is you're expected to do. So for both of these problems that you see here, and I'm going to slide this picture down just a smidge, we are asked to find the average rate of change, right? You can see that here, and you can see that here. And so it might be helpful to remember the formula for the average rate of change. It's f of b minus f of a over b minus a. Essentially, it's your old slope formula from algebra class, except we fancied it up by calling the y values f of b and f of a instead of y2 minus y1. So as long as you know what the parts are in these problems, you should be good to go. Now we start right off in number 1 with a dirty trick. The function is e to the x. And we haven't talked a lot about exponential functions recently, so you may have a little shell shock going on here. But we're going to leave these in terms of e, and I think you'll see when we do these that it's not as bad as it looks. So let's just not panic and let's see what we can do. So we need a and b, and that's what these intervals are. This number here is a, -2, and the number 0 is b. So we're just going to plug these numbers in like this formula says and see what we come up with. Since our formula is e to the x, we're going to plug in 0 for the first time, so that's e to the 0, minus, plugging in a would be e to the -2, and then we have to divide by 0 minus -2. And if you do that, you're almost done. Like we've done the new math. We just need to simplify a little. So just realize that e to the 0 is just a 1. And since it says leave it in terms of e, I'm just going to write e to the -2, and I'm not even worried about the fact that that is a negative exponent. There's fancy algebra we can do to clean that up, but we're not in fancy algebra class right now. We're learning about average rate of change in calculus class, and we don't need to get crazy on this thing. 0 minus -2, we can get crazy on that and just make that into a 2. And then as far as I'm concerned, if you made it this far, you're in good shape. If you want me to show you later how to simplify 1 minus e to the -2, I can do that. But that has nothing to do with the calculus of this problem. The calculus of this problem is computing average rate of change, and it's barely calculus. But that means just plug the stuff into the formula like we did here. So if you made it here, you're in great shape. We're going to play the same game down here with a equals 1 and b equals 3. It'll be e to the 3 minus e to the 1 over 3 minus 1. And then a little bit of simplifying, we're going to get e cubed minus e over 2. And again, if you made it here for what we're doing now, that is fine. We haven't practiced with exponential functions lately, so we won't worry about how to simplify those expressions. The same is true when you come down here to this cotangent of x. We haven't practiced the trig functions in a while, so let's not freak out about this thing. Let's plug the numbers in, and you can cheat and look at your unit circle for the values. So we're going to do cotangent of 3 pi over 4, because that's f of b, minus cotangent of pi over 4, because that's f of a, divided by 3 pi over 4 minus pi over 4. And if you made it there, you've done the new stuff. It would be nice to simplify this a little. If you go to your unit circle, the cotangent of 3 pi over 4, remember that's the x-coordinate divided by the y-coordinate. That's going to be negative square root of 2 over 2 divided by square root of 2 over 2, so that's a -1. And then the cotangent of pi over 4, that's in the first quadrant, that's the square root of 2 over 2 divided by the square root of 2 over 2, so that's just a 1. So this is -1 minus 1. And then these fractions down here on the bottom, we can subtract these, and that's just pi over 2. 3 pi over 4 minus pi over 4 is 2 pi over 4, which simplifies to pi over 2. So essentially we get -2 divided by pi over 2. Now that is a complex fraction, but you can simplify that into -4 over pi. So if you want to get fancy and do all the trig, you'll end up at -4 over pi. But just keep in mind, if you were able to do this, write out the f of b minus f of a over b minus a, then you've done the new stuff. You've done the average rate of change. You just need help simplifying. Very similar math down here on this end. The cotangent of pi over 2 is going to be 0 because that's 0 divided by 1 on the unit circle. The cotangent of pi over 6, that's going to be square root of 3 because it's square root of 3 over 2 divided by 1/2, which is square root of 3. And then on the bottom, it's pi over 2 minus pi over 6. That's going to be pi over 3, I guess. So I think this thing all simplifies to 3 square root of 3 over pi. Again, off the top of my head, I'm worried that you set this fraction up. Then you know, practice your trig and do some simplifying and look on your unit circle. And the truth is you probably should be able to get to an answer something like this. But the world hasn't ended if you are a little rusty on your trig. As long as you are using our formula up here for the average rate of change to set up that calculation, then you've done what we learned. So far, so good. Let's move on to number 3. So on number 3, we are asked to find the slope of the curve at an indicated point. And we have a new formula for that as well. To find the slope of the curve, you're going to do the limit on the difference quotient. So the limit as h goes to 0 of f of a plus h minus f of a over h. That's how we get the slope of 1 point. And so as long as we know what f is, and we do, it's right here, x squared plus 2x. And as long as we know what a is, and we do, it's x equals 2, so a equals 2 here, we should be able to set up this limit and get that slope. And that's what I'm going to do right here. So I just start writing out the limit. Essentially, since a equals 2, I'm going to plug 2 plus h into my function. Then I'll subtract f of 2 and divide that by h. Now, don't get me wrong. This is not fast. F of 2 plus h is an algebra mess, but it's not hard. You just have to be careful, go slowly, and take your time. So we do that composition. We plug in 2 plus h into the function. So it happens in 2 places. I plug 2 plus h in where it says x squared, and I'll do 2 plus h squared. And a lot of times students have trouble multiplying this binomial out. They always put 4 plus h squared. They don't do the middle terms. So don't forget you have to distribute there. Remember your old FOIL from algebra class. We also have to plug 2 plus h in where the x is. So that's 2 plus h. That's 2 times 2 plus h. All of that is just for this first piece here, f of 2 plus h. Then there's a minus sign, right, in the middle. And now we have to do f of 2. And I'm just going to calculate that in my head. 2 squared is 4, plus 2 times 2 is another 4, so that's 8. So this is f of 2 plus h. This is f of 2, and then that's over h. Now you have to carefully multiply this stuff out so we can evaluate the limit algebraically. So there's still a lot of work to do. 2 plus h quantity squared is 4 plus 4h plus h squared. And then we have to distribute the 2, so that's plus 4 plus 2h, and then don't forget there's a minus 8 on the end over h. Now, this 4 and this 4 add up to 8, so that's positive 8, which cancels out the negative 8. So stuff is canceling on me now. I also have some like terms. I have 4h and 2h, so that's 6h. So when I simplify this, I have 6h plus h squared over h. And just to double check here, because we've done a lot of work, when I plug 0 in, I still get 0 over 0. So I still have more work to do just to get to this slope. So let's do one more round here. I think we can get to the end of this thing. Limit as h goes to 0 of. You'll notice that 6h plus h squared can be factored. So I'm going to factor out an h and get h times 6 plus h over h. I factored this expression, and that is great news because that's going to eliminate my 0 in the denominator. And now when you do substitution, you get 6 plus 0, which is 6. So the slope of the curve at point x equals 2, oops, that was supposed to be a highlighter, is 6. The slope is 6. It took us a lot of math to get there, right? Using this formula for slope, which is our only tool right now, and it turns out there is a better tool that we'll learn soon, a faster tool, more efficient. But this formula is our only tool right now. We are able to compute the slope to be 6. These problems are long. That's why there's not as many of them. But be patient with yourself, and you might make some arithmetic mistakes or things. We won't panic if that happens. Make sure you're following the plan of computing the limit, and just write things down one step at a time. And you should get to a slope. When they ask for slope, you should get a number for your answer, right? Okay, let's look at letter B, where we're also going to find the slope. So same instructions as letter A. They're telling us A equals 2, and then we want to find the slope. So I'm going to go right into the limit. It's the limit as h approaches 0 of f of a plus h. So that means I have to plug a plus h into this function where the x is. So that is going to be 1 over a plus h plus 1. Oops, that's not plus 1, it's minus 1. Then there's a minus sign. Then it's just 1 over 2 minus 1, because that's f of a. And all of that is over h. So this is absolutely a complex fraction. We can do a little bit of simplifying right out of the gate here, because I know a plus h. Because I should have put 2 in there. So pretend this was a 2. Oops. So that guy I'm going to turn into a 2. Because it's not a, it's 2. We already know a equals 2. So 2 plus h minus 1, that does simplify to just h plus 1. So this fraction is 1 over h plus 1, after I made a little mistake there. And then 1 over 2 minus 1 is just minus 1. Still a complex fraction, and still when you plug in 0, you get 0 over 0. So we need to do the math on the numerator here. We need to do 1 over h plus 1 minus 1. For that, we need a common denominator. The common denominator is h plus 1. So we multiply by h plus 1 over h plus 1. So I'm essentially going to do 1 minus h plus 1. But remember, you got to distribute the negative. Okay, so 1 minus the quantity h plus 1 looks like this. 1 minus h minus 1. The denominator, the common denominator, is h plus 1. And then that's over h. And we've talked about how we can simplify the complex fraction by scooching this h up next to the h plus 1. So we've gotten rid of the complex fraction, and we're almost ready to finish this limit up here. Do you agree also that 1 minus h minus 1 is just negative h? So on top I have negative h, and on bottom I have h times h plus 1. And that's great news, because these h's will cancel, and there's just a negative 1 up top. And now when you plug in 0, you get negative 1 over 1, which is negative 1. So the slope for this function at 2, gosh darn, I did it again. The slope for this function at 2 is negative 1. Again, we use that limit slope formula, f of a plus h minus f of a over h as h goes to 0. That's the limit of the difference quotient, to figure out the slope of a curve at a point. And right now there's no way to avoid it. So there's going to be algebra, there's going to be crazy limits. That's why we spent so much time practicing limits in the previous weeks. All right, let's talk about the equations of tangent lines. So problem 4 asks us to find the equation of a tangent line, and it also says normal line. So we'll talk about normal too at the indicated point. Now, we've talked about this in class, so it's no surprise that this is a very trivial example. We're finding the tangent line to a linear function, which means our answer should be 3x minus 4 when we get there. But let's run through the process to make sure it works. And then remember, this x equals 1 is telling us that a equals 1. So to run through this process, first we need a slope, and then we need a point. And by the way, since x equals 1, I think you'll agree that our point is going to be 1 comma negative 1, because when you plug 1 into the function, you get negative 1. So to get our slope, we have to do that limit again. Limit as h approaches 0 of f of 1 plus h. So that's going to be 3 times 1 plus h minus 4 minus f of 1, which we already computed as negative 1, over h. And then we'll simplify this quickly. We're going to have 3 plus 3h minus 4 plus 1 over h. And like I said, this is a trivial problem here. The 3 and the plus 1 cancel with the 4. And since those are gone, I can cancel the h's, and this limit is just 3. And I could have predicted that because it's a linear function, the only slope is 3. Right? Since this slope is 3, the slope of the tangent line has to be 3 because the tangent line is the line. Okay, once you have your slope, we need to use this point slope form to get the equation of the line. And we've rewritten that form a little bit. So our form is going to be y equals, and then we're going to have f of a, for us f of a is negative 1, plus, and then we're going to put our slope, for us the slope is 3, times x minus a. And for us, a is 1. But that's the setup for these problems. When you're writing a tangent line, this is the formula that you use. It's just a calculus version of, oops, I wrote 3. This is going to be an m. We'll put 3 in later, but I want to show you the calculus version of this thing. So the calculus version is f of a plus m times x minus a. And we know all the pieces of this, so the tangent line is pretty straightforward. This is, I'm going to label this because I also want to do the normal line. So the tangent is y equals negative 1, because that's what f of a is, so negative 1 plus 3 times x minus 1. And when you multiply that out, sure enough, you get the equation of the original line, 3x minus 4, which makes sense because, like I said, this is a trivial case where we're doing the tangent of a linear function. So that's the tangent line. Now let's talk about this thing, the normal line. So a normal is perpendicular to the tangent. It goes through the same point, so it intersects the curve at 90 degrees instead of parallel, or instead of bumping up to it. It intersects the tangent at 90 degrees. So essentially all we need to remember is if this is the tangent slope, the normal slope is the opposite reciprocal because it's perpendicular. Normal is perpendicular, so that would be negative 1/3. So in our normal line, we're only going to change the slope. So I'm going to write y equals negative 1 plus negative 1/3 times x minus 1. And then we need to simplify this equation. So it's going to have a different y-intercept, obviously. It can't, we didn't rotate around the y-intercept. So this is negative 1 minus 1/3 x plus 1/3. So this is going to be negative 1/3 x minus 2/3. And that's the equation for the normal line. Assuming I didn't even make any arithmetic mistakes. But the key to these normal problems is that you want the opposite reciprocal slope. So you flip it over and you make it the opposite sign. And then don't forget, this is our new and improved, oh goodness, new and improved point slope form. And we use that after we compute the slope using our limits. Let's check out letter B. Same goal here. We need the slope of the tangent and the normal. For us, a equals 4. And then f of a, I think you'll agree, is 2. Because the square root of 4 is 2. So when we do our slope, m equals the limit as h approaches 0 of. So we're going to do the square root of a plus h, so that would be 4 plus h, minus the square root of 4, which is 2, over h. And right now when you plug in 0, you get an indeterminate form. And then we're going to remember that we have a strategy for solving these things. We're going to multiply by the conjugate. So I'm just going to multiply by 4 plus h, the square root of 4 plus h, plus 2 on top and bottom. And that trick helps us eliminate this radical. So when we're computing the slope, the limit as h approaches 0, we're going to get on top 4 plus h minus 4 when we do the FOIL on the numerator. And then on the denominator, we're just going to write this out. Don't even bother multiplying this because we want stuff to cancel out, and we'll be plugging a 0 in for h. So we're good to go. The good news here is, check this out, a bunch of stuff cancels. So 4 and minus 4 cancel, and these h's cancel. I'm left with a positive 1 on top. So now the real limit that I have to evaluate, limit as h approaches 0, is 1 over square root of 4 plus h plus 2. And so I plug in 0 and I get the square root of 4, which is 2. 2 plus 2 is 4, so this is 1/4 for the slope. The slope of the tangent line is 1/4. And then I'll go ahead and write out that equation. It's going to be y equals f of a, which is 2, plus the slope, 1/4, times x minus a, and a is 4. And then this simplifies. This is for the tangent. I'll do the normal in a minute. For the tangent, I get y equals 1/4 x plus 1 when I simplify that. So that's the tangent line. Y equals 1/4 x plus 1. To do the normal line, I'm going to use the opposite reciprocal slope. So I'm going to use -4. So y equals 2 minus 4 times x minus 4. And that's going to be y equals -4x plus 18. And unless I made a mistake with my arithmetic, we've got the normal line right there. So once you get in the hang of things, we're doing the same kind of math every time. We're doing the limit of the difference quotient. And then, we wrote out a couple equations. One is the tangent line, and the other is the normal line. But the bulk of the work happened up here in the top half of the slide where we were doing the limit. All right, let's talk about a couple of applications. An object is dropped from the top of a 100-meter tower. Its height above the ground after t seconds is given by the function s of t equals 100 minus 4.9 t squared, where s of t is measured in meters. How fast is the object falling 2 seconds after it's been released? Okay, so there's a lot of words in this problem, but this is a typical free fall equation, free fall problem from physics. Because of gravity, because of the acceleration due to gravity, our object is falling, of course hopefully at 9.8 meters per second. And then the way you figure out the distance traveled is the 4.9 t squared minus wherever you started. So we started at 100 and we're subtracting every second 4.9 t squared. Okay, and we are interested in the exact instant of 2 seconds. And the question is, how fast? How fast are we going at 2 seconds? That is an instantaneous rate of change problem. In other words, we are doing the slope of the curve at a point. So this is very similar to number 3. We're doing the slope of the curve at a point. The curve that we're interested in is 100 minus 4.9 t squared. You can imagine that t is an x. And the value of a that we're interested in is 2 seconds. So just make a note that a is 2. If you want to go ahead and compute f of a right now, or s of a, I should say, that would be 100 minus 4.9 times 4. And I think that works out to be 80.4. You can verify that. When you plug 2 into this, you get 4 times 4.9, which is 19.6. 100 minus 19.6 is 80.4. Okay, so let's get that speed, right? How fast? And that's just the slope. It's the limit as h approaches 0 of, and let's use the right word here. We're going to do s of 2 plus h minus s of 2, which we already said was 80.4, over h. And then the key is to be careful how you plug this 2.4 into that formula. So I'm going to write that out here. S of 2.4, that's going to be 100 minus 4.9 times 2 plus h squared. That's just this first piece. That's just this guy. We haven't done the minus 80.4 yet. I'm going to write that in right now. And the other thing I haven't done, which I'm going to have to squeeze in here, is put the limit in. We don't want to lose our limit notation. Oh, it's give me the business. I'm going to put that right here. Limit as h approaches 0. Okay. So let's this is 2 plus h. It looks like 2th, but it's 2 plus h, this guy. All right. Let me write a little neater and slower here because I have to keep track of what we're doing. So I have 100 minus 4.9 times, and I have to multiply out 2 plus h squared. Well, I know that that's 4 plus 4h plus h squared. And then there's still the minus 80.4. And then I'm going to distribute the 4.9, the negative 4.9, so that's 100 minus 19.6 minus 9, let's see, what is, oh, so that's 19.6h minus 4.9, I'm going to run out of room here, h squared, minus 80.4 over h. Sorry about that. The good news is the stuff that I missed here on the end is going to cross out. This makes 80.4, and this is 80.4, so those are gone. And then I can rewrite this, hopefully in the amount of space I have left. I have negative 19.6 h minus 4.9 h squared over h. And I think you'll agree I can factor an h out. This is an h. So I can factor out an h, and then we'll be done with this thing. H times negative 19.6 minus 4.9h over h. The numerator and the denominator h's cancel. I'm going to plug 0 in for this h, and so by substitution, this speed is 19.6, and that is meters per second because we're measured in meters and seconds for our units. I'm making a sigh of relief here because that was a long problem. You have to use this limit definition for the slope to run through all that, and there's a lot of algebra. So I'm not saying it's easy. Again, that's why we don't have as many problems to work on. Okay, number 6 is very similar. You just have to be careful. You have to set up the equation first. They're messing with us just a little bit. The equation for free fall on the surface of Mars is s equals 1.96 t squared. That tells you how far you've fallen after a certain number of seconds. T is measured in seconds here. Assume a rock dropped from the top of a 200-meter cliff. Find the speed of the rock at 1 second. So there's a couple of ways to look at this, but it really doesn't matter how high the cliff is on Mars that we're throwing this thing off. If you want to know the speed of the rock at 1 second, you really just need to focus on this equation. And if you were in class today, you know I got distracted by a comment about this, but it turns out we're going to get the same answer regardless of whether we worry about the 200 or not because those constants cancel out. So let's focus on what matters. What matters is that we want to know our speed at 1 second. So the speed is slope, remember. And we're going to do the limit as h approaches 0. We need to do 1 plus h, so that's going to be 1.86 times 1 plus h, because a is 1, squared, minus 1.86 times 1 squared, which is 1.86, over h. And when you multiply this out, you get limit. Oops, let me do my limit. Come on, man. Limit as h approaches 0. Please don't forget your notation. Don't be in a rush like the old man here. Now we're going to do 1.86 times 1 plus 2h plus h squared minus 1.86 over h. Limit as h approaches 0. And now we've got the 1.86 plus, you're going to have 2 times 1.86, which is 3.72 h plus 1.86 h squared. There's my phone. Hold on a minute. Yeah, that was some telemarketer from Google. So we did a 1.86 h squared minus a 1.86 over h. And then like all of our other limits, good stuff's going to happen. This cancels. You can see I'm going to factor out h, so I'm just going to go like this, cross that one off, and that one off. And now I'm left with this limit. 3.72 plus 1.86h. And I'm going to plug 0 into that. And the 1.86 goes away because it gets multiplied by 0. And we find out that our speed is 3.72 meters per second. And that is, in fact, what we are shooting for. So what you need to know about these physics problems is when you're dealing with gravity, how close you are to the surface of the planet doesn't really matter because the gravity is a constant acceleration. So if we're flying in the air for 1 second, we're going to hit the same speed regardless of where we started. So we're going to hit 3.72 meters per second. Just like in the previous problem, if we were on Earth, our gravity would be 4.9 t squared, our distance traveled due to gravity. Okay, so this is the speed. Now we just need to talk about horizontal tangents, which is in problem 7. Okay, here's our last problem. It says, at what point, and that's a big deal because that's a new question, we haven't been asked that question yet, is the tangent line horizontal? So what you need to know is that lines are horizontal when their slope is 0. So essentially, we want to know when the slope is 0. I was going to try and erase that. It didn't work. Okay, we want to know when the slope is 0. So we got to write out the formula for the slope. We don't know the point. So A is a question mark. That means we're going to have to use the letter A in our formula. And we're going to set our formula equal to 0 because our line is horizontal. So here's what that looks like. The limit as h approaches 0 of, and I'll write out the notation first and then we'll plug the stuff in. We're going to do a plus h with the letter A minus f of a with the letter A over h. And we're going to set that equal to 0. So we're going to we're going to evaluate this side so that we get an expression involving a, and then we'll solve it by setting it equal to 0. All right, here it goes. It's not pretty, but we can do it. We're going to do a plus h squared minus 6 times a plus h plus 1 minus f of a, which is this formula with a plugged in, so that's a squared minus 6a plus 1. So we have f of a plus h minus f of a all over h. Then we need to multiply this all out. I put him instead of lim. Limit as h approaches 0. Okay, so bear with me here. I'm going to multiply this all out. It's going to be a squared plus 2ah plus h squared minus 6a minus 6h plus 1 minus a squared plus 6a minus 1, right? You distribute that negative sign. And if everything went according to plan, a whole bunch of stuff cancels. So I've got an a squared and a minus a squared. I've got a negative 6a and a plus 6a. Ooh, I missed this plus 1 right here, didn't I? There's a plus 1 in here. So this minus 1 and this plus 1 cancel. And I'm left with, after all of that, just a little bit of stuff. I have 2ah plus h squared minus 6h. That's it, over h. And I can factor out an h on the numerator, so that's h times 2a plus h minus 6 over h. And those h's cancel. And then I'm going to plug in 0. And my expression is, oh, and I lost my equals 0 on here. I'm so sorry. This all equals 0, right? We're setting all this stuff equal to 0. Same as this one here. My expression is going to be, if I put 0 in for h, I get 2a minus 6. So this guy equals 0. So I have 2a minus 6 equals 0. And when you solve this, you're going to go plus 6 divided by 2. You get a equals 1.5. So that's the x coordinate. And then if you want to know the y coordinate, oh goodness, I did it again. Oops, I did it again. A equals 1.5. That's the x coordinate. If you want to know the y coordinate, just plug in f of 1.5. I'll leave that for you to get the y coordinate as the end of this video because you don't want to listen to me talk anymore. But that'd be the y coordinate. So at what point x equals 1.5 is the x coordinate, and then we'll compute the y coordinate, and we're done. Okay, lots of stuff in this video. Be patient with yourself. You do not have to be perfect with this today. We're going to work more on this week, and eventually we'll get to some shortcuts that'll help relieve some of the stress of all these crazy limits. For now, hang in there, and I'll see you soon. Take care.